radius of the orbit of the electron and velocity of the electron, Rn and Vn of the electron. Let's explore how the radius and velocity of the electron in Bohr's atom model are derived. Introduction. Here you have the nucleus with charge plus Ze. This nucleus is assumed to be stationary. An electron revolves around the nucleus in circular orbit. It is the nth orbit. The radius of this nth orbit is Rn. Here, the electron is acted upon by the Coulomb force, which acts as a centripetal force. This is shown by a red arrow mark, and the blue arrow mark gives the direction of velocity of the electron in the orbit. The red arrow is always towards the center, gives the centripetal force, and the blue arrow gives the velocity, direction of velocity of the electron in the orbit. F. The electrostatic attraction which provides centripetal force. Vn. Vn is the speed of the electron in the nth orbit. Electron. The mass is m and the charge is minus e. An electron moves in a circular orbit around the nucleus because of the attractive Coulomb force, which act as a centripetal force. An electron moves in a circular orbit around the nucleus because of the attractive Coulomb force, which acts as a centripetal force. Equating the two gives us the basic condition for electron motion. To find the radius of the nth orbit Rn. 1. Force balance in Bohr's atom model. Electron revolves around the nucleus due to Coulomb force. This force acts as centripetal force. So the Coulomb force is 1 upon 4 pi epsilon naught, product of the charge of E multiply Ze. E is the charge of the electron, Z is the charge of the nucleus, divided by distance square Rn square, equals the centripetal force mvn square divided by Rn. From this equation, we get 1 upon 4 pi epsilon naught Ze square upon Rn square equals mvn square divided by Rn. From this equation, we have to find the angular momentum. So, 1 upon 4 pi epsilon naught multiply Ze square divided by 1, the Rn square has gone to the right hand side. So, we get mRn square Vn square divided by Rn. To get the angular momentum square on the numerator, we multiply and divide the right hand side by m. Therefore, what we get on the right hand side is m square Rn square Vn square divided by m times Rn. The Rn on the denominator of the right hand side has gone to the left hand side, and on the left hand side the Ze square has gone to the right hand side denominator. So from this equation we get m square Rn square Vn square. This is angular momentum square. So m square Rn square Vn square equals Rn square multiply mze square divided by 4 pi epsilon naught. Now let us go for quantization, Bohr's quantization condition. angular momentum of the electron in the nth orbit equals n h bar. The angular momentum is given by Ln equals m Vn Rn, which is equals n time h divided by 2 pi. The h bar is replaced by h upon 2 pi. So, m Vn Rn square we found. We bring that here. So, Rn m z e square divided by 4 pi epsilon naught square equals the square of the right hand side is n square h square divided by 4 pi square. From this we found Rn equals epsilon naught n square h square divided by pi m z e square. The Rn we need to find. What are the terms that get cancelled here is 4 and 4 cancel and 1 pi is getting cancelled. So, this epsilon naught has gone to the right hand side. So, we get epsilon naught n square h square on the numerator, and in the denominator we have 1 pi and m z e square. So, Rn equals a naught times n square divided by z. So, the a naught is the combination of all constants like epsilon naught h square divided by pi m e square. The value of this a naught equals 0.529 Armstrong. So, let us write the value of Rn equals epsilon naught n square h square divided by pi m z e square equals a naught times n square divided by z. Remember, the Rn proportional to n square and inversely proportional to z. Bohr radius. For hydrogen atom, Z equals 1. Therefore, Rn equals a naught n square. Bohr radius equals smallest radius of hydrogen atom. This is possible when the electron is in ground state. So, R1 equals simply a naught, which is equals 0.529 Armstrong. Let us go for second orbit. The radius of the second orbit equals 2 multiplied 2, we get 4 times a naught. We multiply 4 by 0.529, we get R2 as 2.116 Armstrong. So, R3 equals 9 times a naught equals 4.761 Armstrong. So, Rn proportional to n square. Here you have the nucleus with the first orbit n equals 1 and the second orbit where n equals 2 and the third orbit where n equals 3. The electron revolves in the third orbit. The radius of the first orbit is simply R1 equals 0.529 Armstrong. The radius of the second orbit is R2, which is 4 times R1. We found that as 2.116 Armstrong. The radius of the third orbit is R3, which is equal to 9 times R1 equals 4.761 Armstrong. The gap between the orbit is getting increases as we go outward. 4. Velocity of the nth orbit electron. Angular momentum of the electron equals n times h bar. So, we know Ln equals m times Vn Rn equals n times h upon 2 pi. The Rn value has to be substituted in this equation. So, we get m Bn multiply a naught times n square divided by z equals n h divided by 2 pi. From this equation, we can find Vn, which is equals h divided by 2 pi m a naught multiply z upon n. Here, one n is getting cancelled, that n as in the denominator. Good. And z is a variable, so that's there separately. Then the constants are collected, they are h divided by 2 pi m a naught. So we found Vn proportional to 1 upon n. So the velocity decreases with principal quantum number. Velocity is maximum in the ground state and decreases with n. On the x-axis, let us take the principal quantum number n, and on y-axis, let us take the velocity of the electron in the nth orbit. Here we get a rectangular hyperbola, Vn proportional to 1 upon n. NEET tips. For hydrogen atom, Z equals 1. The Rn equals A naught times n square. Vn proportional to 1 upon n. Bohr radius equals 0.529 angstrom. This is an important fact. Higher the orbit, the electron farther from the nucleus and its velocity decreases. So Rn equals A naught n square, Vn proportional to 1 upon n, Bohr radius is 0.529 angstrom.